Alright guys, so question 8. Define simple harmonic motion. Okay, this will just go with the distance x of a particle from a fixed point O is given by is given by x equals a cos omega t, where O is given by x a equals a cos omega t plus a, where a, omega and alpha are positive constants. Show that the particle is describing simple harmonic motion about O and calculate omega and alpha if the velocity v equals minus 2a and x equals 3 over 5 when t equals 0. Start off with the easy part, right? First derivative, first thing is write down the equation. Now we're going to do the derivative. So differentiate once, guys, we get dx dt. Now what happens when you differentiate a as a constant? What happens when you differentiate cos? Turns into, is it plus sign or minus sign? Turns into minus sign. The angle remains unchanged. Now, you're differentiating with respect to t. So what gets affected in here when you differentiate it? What? The t. So it's the number that comes beside the t. If you differentiate 2t, you get 2. If you differentiate 2t plus 1, you still get 2. If you differentiate omega t plus alpha, which is a constant, what are you going to get? Just omega, the number that comes in front of the t. So it's omega. So technically speaking, minus a omega sine omega t plus alpha. Is that alright? Okay guys, so that's the first derivative. Second derivative? Can anybody tell me? Second derivative. Once again, this here is considered constant. This is the differentiable part here, underlined in blue. What happens when you differentiate sine? Cos. Angle is maintained. Then you differentiate the angles. What happens when you differentiate the angle? Yeah, omega here. Then it's minus a omega squared cos wt plus a. Okay guys, compare to x. Which parts belong to x? The a does and the cos omega t does. Okay? So it's basically minus omega squared x. What's the second derivative again? If the first one, if the equation is distance, the first derivative is velocity, and the second derivative, guys, acceleration. So technically speaking, you're saying that the acceleration is minus omega squared x. Why does it execute simple harmonic motion? Can anybody remember? Because the acceleration is always in a different direction to the displacement. If x is positive, a is negative. If x is negative, a is positive. Because of this here minus sign. Is that alright? Now that all that's done, we're on to part, we're still on the first part here. It goes, calculate omega and a if the velocity v equals minus 2a when t equals 0. Okay? And x equals 3a over 5. Anybody have a suggestion for using, we need v and we need to link v with either t or x. Which one do you think we can use? We're going to use x. What's that formula again, guys? V squared equals, anybody remember? Omega squared a squared minus x squared. Pretty sure that's it anyway. So, there it is there. Use this formula here. Phi is minus 2a to b squared. Omega, we don't know. A squared, guys. Suppose it just says a squared, doesn't it? We don't really know what it is yet. And what about the other part? This x squared is going to turn into 9a squared over 25. Now, there seems to be a lot of a squareds going on. So much so that I think they're going to be factorizable. So it's going to be 16a squared divided by 25. The a squareds can cancel. The 25 can come over the other side to become 100. 16 omega squared. 100 divided by 16, anybody? 25 over 4. Thank you. Square root that. 5 over 2. Can't know what omega was. 5 over 2. Next thing we have to do is find out alpha. Okay. Which equation is alpha in? Is alpha unique to this question, or is it a generic term, alpha? That's where the alpha is, isn't it? It's unique to this question. I could call that any letter I want. It could be K, it could be M, it could be anything. So it's unique to this question, which means we're going to use this formula here. We're going to use x, your displacement at any time, equals your amplitude times the cos function times omega t plus alpha. What is the x value at t0? X value at t0, guys? 3a over 5 equals a cos omega t plus alpha. Now what's the t value again? It says it here. T is 0. So omega t will therefore be 0. The a's will cancel. Cos alpha is equal to 3 over 5. Therefore, what is cos alpha? Am I in radians? No. Cos inverse 3 over 4, guys, or 3 over 5. What do you get? 0.93927. 0.9273. Okay. So far, I have found out what omega is, and I've also found out what alpha is. Okay? So, you go there. Now, next part. After how many seconds from the start of the motion is x equals 0 for the first time? Okay, guys, it's a cos function. What does that mean? Sorry? Radians? It says R. I was meant to have it in R. Everything's done in radians. Okay. Shh. Okay. Oh, I need to wear this. Ugh. So, anyways, okay. So, what we get next, guys, is after how many seconds from the start of the motion is x equals 0 for the first time? When is x equals 0? Now, remember what we said earlier, that when you have a standard cosine function, actually best do it here. When you have a standard cosine function, an example would be y equals cos 2x, okay? Y equals cos 2x, no bother. You have a standard wave function, okay? Now, what the amplitude does, the a value does, is the a value will either make it taller. If I had an a value of 2, it'd go as far as 2. Okay, so that's your cosine function. Your cosine function, this is the height of the graph above the x-axis represents your displacement. An example would be, I'm a distance 1 meter away from displacement at t equals 0. About 0.8 of a second, I'm back at the equilibrium point. At about 1.4 seconds, I'm at the maximum distance away from the middle, the other side. Back to the center again, back to the positive displacement, back to the negative displacement. Now, if I use the same function, did I use cos 2x, didn't I? So if I use cos 2x plus 2, so you notice I'm adding in an extra plus 2.
What this plus 2 does is it offsets it. See the way it's out of phase now? This means that at t equals 0, I actually started off not at the extremity, but in between. I was neither in the equilibrium position or at the amplitude. I was in between, okay? And we had to find out where do we hit it for the first time, okay? So if I was to do this now, I know my function. My function here is x equals a. Now, do we know the a value yet? How many seconds is the start of the motion is x equals 0. So we only need to find out when x equals 0. So we actually don't need to know the a value to pull this off. Okay? So we go x equals, where is it? X equals a cos. Now we know the omega value, don't we? Omega value is 5 over 2t. And we know the alpha value. What's the alpha value? 0.9273. Okay, and we know that it wants the displacement to be 0. It wants x to be 0. So basically it wants you to have 0 displacement away. So x equals 0. Okay, so what we're going to get here is this, guys. Ready? Will somebody take down this formula as well for me, because I'm going to use it in a second for just another point, okay? So x equals 0. So 0 equals, now the a value is irrelevant, so it's going to be cos 5 over 2t plus 0.9273. What's cos inverse 0, guys? Cos inverse 0. Sorry? Pi over 2. Any other answers? Plus 2 pi, isn't it? So, sorry, plus pi. Because it'll also be 0 at 3 pi over 2. And 5 pi over 2. In layman's terms, 90 degrees, 270 degrees, and 450 degrees. Cos is always 0. You wanted the first value, didn't you? The first value in line is pi over 2. So this pi over 2 here must be equal to the angle 5 over 2t plus 0.9273. Bring over your 0.9273 and take it away from pi over 2. So you're going to have here pi over 2. Take away your 0.9273. Right? And then you're going to divide it by 5 over 2, aren't you? To isolate t. So 5 over 2t. 1 second. Take away your minus 99273. You're going to divide by your 5 over 2. And what you're going to get here, guys, is 0.257. Your time taken is 0.2573.